So today let's discuss questions of generating lines. So the question 1 says that find the equation of generating lines of this hyperboloid and which is passing via this given point. So the given point P to us is 2, 3, minus 4, and given equation of hyperboloid is x square by 4 plus y square by 9 minus z square by 16 is equals to 1. So I can write this given equation of hyperboloid like this: x square by 4 minus z square by 16 is equals to 1 minus y square by 9, which I can further write as x by 2 minus z by 4 into x by 2 plus z by 4 is equals to 1 minus y by 3 into 1 plus y by 3. So this will basically give me the equation of two family of generators. So let a lambda family of generators be, I can write above equation as x by 2 minus z by 4 divided by 1 minus y by 3 is equals to 1 plus y by 3 divided by x by 2 plus z by 4. And I can equate it with some constant lambda to find two equation of planes whose intersection will basically give me the equation of generating line. So if I simplify it, I will get x by 2 minus z by 4 equals to lambda into 1 minus y by 3, which is basically equals to x by 2 plus lambda y by 3 minus z by 4 is equals to lambda, and this second term will basically give me x by 2 plus z by 4 is equals to 1 by lambda into 1 plus y by 3, and this will basically give me x by 2 minus y by 3 lambda plus z by 4 is equals to 1 by lambda. So we got basically two equations of plane, and their intersection will give me equation of one generating line. So since the question says that this generating line passes via this point, so these must be satisfying equation of both these planes. So let us just substitute value of this point in the two equation of plane and find out value of lambda. So if I do so, in the first equation of plane, I'll get 2 by 2 plus lambda minus 4 by 4 is equals to lambda, which basically gives me 1 plus lambda plus 1 plus lambda. So from here I got 2 is equals to lambda into 0, so which doesn't hold for any finite value of lambda. It just hold only when lambda is basically my infinity, or I can say 1 by lambda approaches 0. That's the only conclusion I can draw from here. Likewise, if I substitute the value of the given point in this generating plane, I get 2 by 2 minus 3 by 3 lambda minus 4 by 4 is equals to 1 by lambda. Which basically gives me 1 minus 1 by lambda minus 1 is equals to 1 by lambda. So from here I get 0 equals to 1 by lambda, which also gives the same value, 1 by lambda is equals to 0. So if I just substitute this value of 1 by lambda in the above equations of plane, I will get 1 by lambda is 0. So if I do so, I'll get x by 2 plus z by 4 is equals to 0. And from this one I'll just take this lambda on other side, and I'll get 1 minus y by 3 is equals to 0. So the equation of planes that I have is basically 2x plus z equals to 0 and y equals to 3. So this is basically the equation of one generating line, that is the generating line formed by the lambda family of generators. So I can assume that let L, M, N be direction cosine of the generating line, which I got by intersection of these planes. So direction cosine of this generating line will be perpendicular to direction cosines of normal of this plane and this plane as well. So using the perpendicularity result that says L1 L2 plus M1 M2 plus N1 N2 equals to 0, I'll get 2L plus N equals to 0 and M equals to 0. So if I simplify it, I'll get 2L equals to minus N and M equals to 0. So from here I get L by minus 1 equals to N by 2 and M is equals to 0, which basically gives me L by minus 1 equals to M by 0 equals to N by 2. So these are basically the direction cosines of the generating line of lambda family. Likewise, I can assume mu family as well, mu family of generators, as I can write our this equation as this: x by 2 minus z by 4 upon 1 plus y by 3 is equals to 1 minus y by 3 divided by x by 2 plus z by 4. So if I equate it with mu, I'll basically get x by 2 minus z by 4 is equals to mu into 1 plus y by 3, which on simplifying I'll be getting x by 2 minus mu y by 3 minus z by 4 is equals to mu. Likewise, I can equate these two and find out equation of plane. That basically gives me x by 2 plus z by 4 is equals to 1 by mu into 1 minus y by 3, which on simplifying I get x by 2 plus y by 3 mu plus z by 4 is equals to 1 by mu. So these are basically two equation of planes, and the intersection of these two planes will basically give me the mu generator. So that I'll be getting by substituting the given point, as it's passing via generator. So the given point is 2, 3, minus 4. So if I substitute P, that is 2, 3, minus 4 in the given equation of planes, I'll get 2 by 2 minus mu into 3 by 3 plus 4 by 4 equals to mu, which basically gives me 1 minus mu plus 1 equals to mu. So from here I got 2 mu equals to 2, which basically gives me mu equals to 1. Let us substitute this value in this plane as well and see if it satisfies. So if I substitute P in other plane, I basically get 2 by 2 plus 1 by mu minus 1 by 4 is equals to 1 by mu, and mu is my 1, so it basically gives me 1 plus 1 minus 1 is equals to 1. So it is giving me 1 is equals to 1. So the given mu satisfies this as well. So mu is equals to 1 for mu family of generators. So the given equation of planes I got is x by 2 minus y by 3 minus z by 4 is equals to 1, and the another one is x by 2 plus y by 3 plus z by 4 is equals to 1. So now let us assume that L dash, M dash, N dash be direction cosine of the intersecting lines, and then using perpendicularity result I'll be getting L dash by 2 minus M dash by 3 minus N dash by 4 equals to 0, and L dash by 2 plus M dash by 3 plus N dash by 4 equals to 0. So this is basically equals to 6L dash minus 4M dash minus 3N dash equals to 0, and this one is equals to 6L dash plus 4M dash plus 3N dash equals to 0. So I can solve these two equations for L dash, M dash and N dash using the cross multiplication, that basically gives me minus 12 and plus 12 0 equals to minus m dash. This gives 18 plus 18 and n dash is basically 24 plus 24. So which on simplifying I get L dash by 0 equals to m dash upon minus 36 is equals to n dash upon 48, and I can divide throughout by 12, so my L dash is 0, m dash is minus 3 and n dash is 4. So the two generator lines, I got the direction cosines of two generator lines. So for lambda family, direction cosines are these, and for mu family, direction cosines are these. And since it is given that the direction cosines are passing via fixed point, that is 2, 3, minus 4, so the equation of generator lines would be, is basically x minus 2 by minus 1 equals to y minus 3 by 0 is equals to z plus 4 by 2. And equation of another generator line is x minus 2 by 0, y minus 3 by minus 3 and z plus 4 by 4. So these two lines basically give the generator lines. So let us move on to next question. So the next question says that find the locus of point of intersection of perpendicular generators of hyperbolic paraboloid. Okay, so we are given two perpendicular generators. So the given equation of paraboloid is basically x square by a square minus y square by b square is equals to 2z. So I can write it as x by a minus y by b into x by a plus y by b is equals to 2z. So from here I'll be getting basically two family of generators. One is this one, z upon x by a plus y by b. Let's say it is lambda family of generators, and another one is x by a plus y by b. Let's name it as mu family of generators. So if I simplify it, I'll be getting two planes, so and whose intersection will basically give me the line of intersection. So and that line of intersection is basically generator of the hyperbolic paraboloid. So if I simplify it, I will get x by a minus y by b is equals to 2 lambda, and from second one I will get x by a plus y by b minus z by lambda is equals to 0. And from another one, that is the mu family, I'll get generators as x by a minus y by b minus z mu equals to 0 and x by a plus y by b is equals to 2 by mu. So these are basically two generators. So let us assume that L1, M1, N1B direction cosines of generator of lambda family. If that's the case, then using perpendicularity result, line of intersection will be basically perpendicular to the normal to these planes. So if I use perpendicularity result, I'll be getting L1 by a minus M1 by b plus 0 into N1 is equals to 0, and L1 by a plus M1 by b minus n1 by lambda is equals to 0. I can solve these two equations to get basically L1, M1 and N1. So my L1 is basically B lambda 1 upon B lambda minus M minus 1 upon A lambda, and N1 is 2 divided by AB. So which is also equals to L1 upon A, M1 upon B is equals to N1 upon 2 lambda. Likewise, I can assume that let L2, M2, N2 be direction cosines of generator of mu family. So if that's the case, the normal to these planes will be perpendicular to the direction cosines of this generator line. So using that, I will be getting L1 by A minus L2 by A minus M2 by B minus N2 mu is equals to 0, and L2 by A plus M2 by B plus 0 N2 equals to 0. And I can solve these equations for L2, M2 and N2. So I'll be getting mu by B is equals to minus M2, which basically gives mu by A is equals to 2 by AB, which is also equals to L2 by mu A equals to M2 by minus mu B equals to N2 by 2. So these are basically the direction cosines of the generators. This one is for lambda family and this one is for mu family. And the question further says that we're supposed to find the locus of intersection points of perpendicular generators. So it is given that these two generators are perpendicular to each other, and if that's the case, then L1 L2 plus M1 M2 plus N1 N2 must be 0. Then if I substitute these values from the direction cosines of generator, I'll be getting mu A square minus mu B square plus 4 lambda is equals to 0, which basically gives you mu into A square minus B square plus 4 lambda is equals to 0. And I can just substitute value of mu and lambda here to get the locus of the point of intersection. And from above, my mu is basically x by A minus y by B by z, x by A minus y by B divided by z into A square minus B square plus 4 times lambda, that is and my value of lambda is basically z upon x by A plus y by B. Which is equals to 0, and this is basically the required locus. One can further simplify it, so we'll be getting x square by A square minus y square by B square into A square minus B square plus 4z square is equals to 0, and x square by A square minus y square by B square is basically 2z, so it is 2z into A square minus B square plus 4z square is equals to 0, which basically gives us 2 into A square plus a square minus b square, sorry. So it gives us a square minus b square plus 2z is equals to 0. So that this is basically the required locus of point of intersection of the generators. So let's move on to next question. So the next question says that find the equations of generating lines of this paraboloid and the generating lines passes via 1, 1, 1. So it is similar to the previous question number 1 that we have solved. The difference is in that they have given us elliptic paraboloid, I guess. So let us solve this. So we can write this given equation of paraboloid as x plus y plus z into 2x plus y minus z is equals to 6z. So I can write it as x plus y plus z divided by z is equals to 6 upon 2x plus y minus z. So if I equate it with lambda, I'll be getting a lambda family of generator, and I can write above equation of paraboloid as x plus y plus z divided by 6 is equals to z upon 2x plus y minus z. And if I equate it with mu, I'll get mu family of generators. So I can solve it to find out value of lambda and mu. That will be basically, so from lambda family of generators I'll get two equation of plane that are x plus y plus 1 minus lambda z is equals to 0, and another one is basically 2x plus y minus z is equals to 6y lambda. And like, let us assume that L, M, N be direction cosines of the generating line. So these generating lines will be basically perpendicular to the normal to both these planes. So using the perpendicularity result, I'll get L plus M plus 1 minus lambda into N is equals to 0, and 2L plus M minus N is equals to 0. So these are basically relation for finding direction cosines of lambda family of generators. Also the question says that generator passes via 1, 1, 1. So if it passes via 1, 1, then that point must be satisfying these two family of planes. So if we substitute that, we'll be getting 1 plus 1 plus 1 minus lambda is equals to 0. So from here I got my lambda as 3, and let us just substitute it in second equation of plane and see if it satisfies. So we get 2 plus 1 minus 1, which is basically 6 by 3 is equals to 2. So this value of lambda satisfies another plane as well. So my lambda is 3. So my direction cosines basically become 1 minus 3 is minus 2, so it is minus 2, and I can solve these two equations to get value of L, M and N. So I'll be getting L as minus 1 plus 2, that is 1, minus M into minus 1 plus 4, this is 3, and my N is basically 1 minus 2 minus 1. So my direction cosines of lambda family of generators are 1, minus 3, 1. Likewise, if we solve for mu family, we'll get two equation of planes as x plus y plus z is equals to 6 mu, and 2x plus y minus z is equals to z by mu, which is basically 2x plus y minus 1 plus 1 by mu into z is equals to 0. Now let us assume that L dash, M dash and N dash are the direction cosines of mu family of generators, and using the same result as we did for lambda family, we will be getting L dash plus M dash plus N dash is equals to 0, and 2L dash plus M dash minus 1 plus 1 by mu N dash is equals to 0. and since the second generator is also passing by a 1 comma 1 comma 1, so using that I'll be getting my mu as 1 plus 1 plus 1 3 by 6, that is 1 by 2. Let us substitute here and to see if it satisfies. Yeah, so this will basically be 2 plus 1 minus 1 plus 2 into 1, which is basically 3 minus 3, which is 0. So this value satisfies this as well. So my mu is basically 1 by 2. So the given relation in element and reduces to minus 3 n dash. So now I can solve these for L dash, M dash and N dash. So I'll be getting L dash as minus 3 minus minus 4, M dash as minus 3 minus 2 minus 5, and N dash will be basically 1 minus 2 minus 1. So direction cosine of a mu family of generators are basically 4 comma 5 minus 4 comma 5 comma minus 1. Now since it is given that the generating lines passing via 1 comma 1, and we have basically direction of both mu family and lambda family, so we can basically find the equation of generating line. That is equation of generating line will be basically x minus 1 by 1, y minus 1 by minus 3 and z minus 1 by minus 1, and equation of another generating line will be x minus 1 by minus 4, y minus 1 by 5, z minus 1 by minus 1. So these two are basically the generating lines that are passing via the given point. So let's move on to next question. So the next question says that find the locus of point of intersection of this is a basically repeated question. The question number 2 that we have done is similar to this one. So let's move on to next question. So the next question says that, so in this question we are supposed to find the equation of two generating lines which are passing through this point on the elliptic section of a hyperboloid in the plane z equals to 0. So hyperboloid in plane z equals to 0 would be basically x square by a square plus y square by b square minus z square by c square is equals to 1. So this is basically the equation of hyperboloid in the plane z equals to 0. So the question says that equation of generating line passes via any point of form a cos theta comma b sin theta comma 0. So equation of generating line will be basically x minus a cos theta upon L is equals to y minus b sin theta upon m is equals to z minus 0 by n. So this is basically an equation of generating line passing via this, and I have assumed that the direction cosines of that line are by L comma M comma N. So if I equate it with R, I will be getting any arbitrary point on generating line. So that will be basically LR plus A cos theta comma MR plus B sin theta comma NR. So this is any arbitrary point on generating line, and since generating line lies completely on the ellipsoid, on the hyperboloid, so this point must be satisfying equation of hyperboloid. So that gives me 1 by a square into LR plus a cos theta whole square plus 1 by b square into MR plus b sin theta whole square minus n square r square by c square is equals to 1. So if I simplify it, I'll be getting r square into L square by a square plus m square by b square minus n square by c square plus 2r into L upon a cos theta plus m upon b sin theta plus cos square theta plus sin square theta is equals to 1. So I can write it as L square into R square into L square by A square plus M square by B square minus N square by C square plus 2R into L by A cos theta plus M by B sin theta is equals to 0, because this term is also 1, so this one balances out this one. So I got this as a relation, but it is given that this line is acting as generator, so any arbitrary point will be a line satisfying this for all values of r. So from here I'll be getting basically L square by A square plus M square by B square minus N square by C square is equals to 0, and L by A cos theta plus M by B sin theta is equals to 0. So I can write the second term as L by A cos theta is equals to minus M by B sin theta, which basically gives me L by A upon sin theta is equals to M by B upon minus cos theta. But since we know a relation in between L, M and N, so we can find out value of N from there. So that is basically L square by A square plus M square by B square under root is N by C. So that basically gives me under root sin square theta plus cos square theta. So from here I got my L as A sin theta, my M as minus B cos theta, and N as C. This will be basically plus minus C, because from here I'll get 1 and it can be both positive and negative. So the required equation of generating line will be basically equation of generator's line will be basically x minus A cos theta upon A sin theta is equals to y minus B sin theta upon minus B cos theta is equals to z minus 0 upon plus minus C. So this is basically equation of generating lines. So let's move on to next question. So the question says that a variable generator meets two generator of the system passing via extremities B and B dash of the minor axis of principal elliptic section of this hyperboloid in P and P dash, and we are supposed to prove that BP dot B dash P dash is equals to this term. So the question says that if this is my given hyperboloid, minus z square by c square is equals to 1, and let us assume that x-axis is the major axis and y-axis is minor axis. So yeah, and the hyperboloid is basically, you can observe that it is basically around the z equals to 0 plane. So the principal elliptic section will be basically x square by a square plus y square by b square. So the question says that the variable generator meets two generator of systems which are passing via minor extremities, that is b and b dash. So minor extremities will be basically 0 comma b comma 0 and 0 comma minus b comma 0. This is b, this is b dash. So the variable generators meet these two generators passing via this and this at point p and p dash, and we're supposed to prove this relation. So any variable generator of hyperboloid passing via principal section will be basically x minus a cos theta upon a sin theta is equals to y minus b sin theta upon b cos theta minus b cos theta is equals to z minus 0 upon c, and another will be x minus a cos theta upon a sin theta is equals to y minus b sin theta upon minus b cos theta is equals to z minus 0 by minus c. So these are basically variable generators variable generators of hyperboloid with respect to the principal elliptic section. This we have proved in previous question only. This will be basically 1 by c and minus 1 by c, because in previous question equation of hyperboloid is, we have assumed this as equation of hyperboloid, but herein our equation of hyperboloid is this one. So accordingly we have changed the equation of generators. So let's name it this equation as 1, this as 2, and let's name it as 3. So the question says that these variable generators are meeting generators passing via minor extremities with respect to minor axis. So if this is my equation, then generators with respect to generators which are passing via extremities, generators which are passing via extremities of minor axis would be basically when my theta is 90 degree and when my theta is minus 90 degree. Likewise, if it asks with respect to major axis, then you can choose theta as 0 and 180 degree. So equation of generator when theta is 90 degree will be basically x minus cos 90 is 0, so divided by a is equals to y minus b by 0 is equals to z upon 1 by c. Let's name this equation as 4, and likewise equation of another would be x by minus a is equals to y plus b by 0 is equals to z by minus 1 by c. Let's name this equation as 5. So the question says that P is basically the intersection point of this and this generators. So let's equate it with some terms and just find out any arbitrary point therein. So if I equate it with, let's say, k1 and this will k2, so their intersection point I'll get by equating and solving the equations. So any arbitrary point on 3 will be a cos theta plus a sin theta into k1 and b sin theta minus k1 into b cos theta comma minus k1 by c, and arbitrary point on 4 would be basically a k2 comma b comma k2 by c. So if these two lines intersection, then there must be a common point in between them. So we'll just equate these 2 points to find out the value of k1 and k2 for which these lines intersect. So that basically gives us a cos theta plus a sin theta dot k1 is equals to a k2 and b sin theta minus k1 into b cos theta is equals to b, and minus k1 by c is equals to k2 by c. So from this one I got k1 is equals to minus k2, and if I substitute this value in this one, I'll get a cos theta is equals to a k2 plus a k2 sin theta. So from here I got my k2 as cos theta upon 1 plus sin theta. If this is my k2, then my k1 is basically minus cos theta upon 1 plus sin theta. So let's just substitute this value herein and see if it is satisfying this equation as well. So it gives b sin theta minus k1 is cos theta upon 1 plus sin theta into cos theta is equals to b. So if I solve this, I'll be getting b 1 plus sine theta into sine theta plus cos square theta is equals to b, which is basically b sine theta, which basically gives me b plus b sine theta plus b sine square theta plus b cos square theta is equals to b. So from here I got b sine theta is equals to 0. I guess we did some mistake above. Okay, when we are solving this, we have taken LCM as 1 plus sine theta. So that 1 plus sine theta will be here as well. So I'll be getting basically, this is b is equals to b plus b sine theta. So this satisfies this as well. So my k1 is this and my k2 is this. So their intersection point, let's name it as p, will be basically a into k2, a cos theta upon 1 plus sine theta, comma b, comma k2 by c, that is cos theta upon c into 1 plus sine theta. Likewise, we can solve for other generators as well. That will be basically intersection point of 2 and 5. So let me just erase some of it and see. So I got my p point as, so my p point is, p is basically a cos theta upon 1 plus sine theta, comma b, comma cos theta upon c 1 plus sine theta. Likewise, my p dash will be basically intersection point of 2 and 5. So any arbitrary point on 2 would be, let's equate it with some term. Let's equate it with p1 and this with p2. So if I equate with p2, then any arbitrary point on 2 would be basically a cos theta plus a p1 sin theta, comma b sin theta minus b p1 cos theta, comma p1 by c. Likewise, any arbitrary point on 5 would be minus a p2, comma minus b, comma minus p2 by c. So if these two are intersecting, then there must be a common point in between them. So we'll just equate these two and solve for value of p1 and p2 and we'll find the intersection point. So if I do so, I'll be getting a cos theta plus a p1 sin theta is equals to minus a p2 and b sin theta minus b p1 cos theta is equals to minus b, and p1 by c is equals to minus p2 by c. So if I solve, I'll be getting p1 is equals to minus p2. So if I use this relation here, I'll be getting a cos theta plus a p1 is minus p2 minus p2 sin theta is equals to minus a p2. So from here I'll be getting p2 as a cos theta upon a sin theta minus 1. So this is my p2, and from here my p1 will be a cos theta upon 1 minus a sin theta. Now let us just substitute this value of p1 and p2 here and see if it satisfies this or not. So this gives b sin theta minus b into p1, that is a cos theta upon 1 minus a sin theta is equals to minus b. It is b into p1, that is a cos theta, into cos theta. So if I simplify it, I'll get b sin theta into 1 minus a sin theta minus AB cos square theta is equals to minus B into 1 minus A sin theta. So if I simplify it, I'll get B sin theta minus AB sin square theta minus AB cos square theta is equals to minus B it is A here as well minus BA plus AB sin theta, and here also there will be A. So if I simplify it, I'll be getting AB sin theta minus AB is equals to minus BA plus AB sin theta. If you see that both left hand side and right hand side are equal, so my P1 and P2 are these, and using this I can find out my value of P dash. So my P dash point will be basically minus A cos theta upon sin theta minus 1 minus B minus cos theta upon C into sin theta minus 1. So I got my P dash as basically my P dash is minus A cos theta upon sin theta I can write it as like this as well. It is A cos theta upon 1 minus sin theta comma minus B comma cos theta upon C into 1 minus sin theta. Now I have values coordinates of both B, P, B dash, P dash. So my B is basically 0 comma B comma 0 and B dash is 0 comma minus B comma 0. So PB would be basically PB or BP. I can calculate using direction formula. So distance formula. So BP will be basically under root 0 minus A cos theta upon 1 plus sin theta whole square plus B minus 0 square plus minus cos theta upon C into 1 plus sin theta square. So which basically gives BP as under root A square cos square theta plus cos square theta upon one plus sin theta whole square upon C square into 1 plus sin theta whole square. Likewise my P dash will be is equals to under root minus A cos theta upon 1 minus sin theta whole square plus 0 square plus 0 minus cos theta upon C into 1 minus sin theta whole square. So if I further simplify, my BP will be A square into C square cos square theta plus cos square theta upon C square into 1 plus sin theta whole square raised 1 by 2, and my B dash is basically A square C square cos square theta plus cos square theta upon C square into 1 minus sin theta whole square raised 1 by 2. So my BP dot B dash is basically A square C square plus 1 into cos square theta upon C square into 1 plus sin theta whole square raised 1 by 2, and B dash is A square C square plus 1 into cos square theta upon 1 minus sin theta whole square raised 1 by 2. So which is basically is equals to a square c square plus 1. From here I am taking a square c square plus 1 under root common, so that will give me a square c square plus 1 into cos square theta upon c square into 1 minus sine square theta, that is basically cos square theta. So I got relation as a square c square plus 1 upon c square. So my bp dot b dash p dash is basically a square plus 1 by c square. So this is the relation I got. I guess this is what we are supposed to prove. No, this is not the relation that we are supposed to prove. So we are supposed to prove a square plus c square. I guess there is some mistake in formation of question, because a square plus c square will get a square plus c square only when it is z square by c square. And to prove that, you can use the similar method, but just there will be change here. In here you'll get c and here minus c, and you can solve that as well. But for this hyperboloid, we'll be getting this only a square c square plus 1 by c square. So let's move on to next question. So the next question says that show that the generators through any one of the ends of equiconjugate diameters of principal elliptic section of this hyperboloid are inclined at 60 degree is this. So first let us write any equation of any generator which is passing via diameter of principal elliptic section. So the given hyperboloid is y square by b square minus z square by c square is equals to 1, and its principal elliptic section would be basically x square by a square plus y square by b square equals to 1 comma z equals to 0. So any arbitrary point on principal elliptic section would be basically a cos theta comma b sin theta comma 0. So we have already seen equation of generator which is passing via any point of this principal elliptic section. So equation of generators would be x minus a cos theta upon a sin theta is equals to y minus b sin theta upon minus b cos theta is equals to z by plus minus c. You can just remember this because it comes handy in many questions. Like you cannot solve it in every question, like depending on the marks and the number of pages given, you can just move ahead and find out equation of these generators. For this question I am using it directly because we have already proved it above in previous questions. So this would be the equation of generator. So let us assume that they are inclined at angle alpha. So my cos alpha will be basically a sin theta into a sin theta plus minus b cos theta into minus b cos theta plus c into minus c, and divided by under root a sin theta whole square plus minus b cos theta whole square plus c square under root a sin theta whole square plus minus b cos theta whole square plus c square, which basically gives cos alpha as a square sin square theta plus b square cos square theta plus minus c square divided by a square sin square theta plus b square cos square theta plus c square. These two terms are same, so under root will be vanished. So this we got cos alpha as this. So also, if you observe in question, it says that it is passing via equiconjugate diameters, and we know that equiconjugate diameters are basically conjugate diameters with equal length, and they make basically angle either 45 degree or 135 degree with a major axis. So if I take my theta as 45 degree, so my cos alpha will be basically a square by 2 plus b square by 2 minus c square divided by a square by 2 plus b square by 2 plus c square, which is basically a square plus b square minus 2c square divided by a square plus b square plus 2c square. Likewise, even if I take this as angle, then also I'll be getting the same term, because there is a sine square theta, so there won't be any change in this. So question says that these two generators are inclined to each other at an angle of 60 degree. So they have given as alpha as 60 degrees. So from here I got cos 60 is equals to a square plus b square minus 2c square divided by a square plus b square plus 2c square. So I know my cos 60 is 1 by 2. So from here I got 1 by 2 is equals to a square plus b square minus 2c square divided by a square plus b square plus 2c square. So if I simplify it, I will be getting a square plus b square plus 2c square equals to 2a square plus 2b square minus 4c square. So which is basically equals to a square plus b square minus 6c square equals to 0. And this is the relation which we are supposed to prove when they are inclined to each other at angle 60 degree. And question also says that find the condition for the generators to be perpendicular to each other. So if they are perpendicular to each other, then my alpha would be basically 90 degree, and I know that cos 90 is 0. So the condition for that will be basically a square plus b square minus 2c square is equals to 0. So this is the condition when my equiconjugate diameters are basically perpendicular to each other. So that's all. Only these many questions I have asked related to this generating lines concept. Thank you for watching.